Sorry for that. I just muted my mic and I'm not even aware of it. So sorry for that. We faced some little issue. Uh, so there is a problem with my power connection. So just kind of annoying and cutted my live. So sorry for that. And so hopefully we can cover something today. Cover some few chapters and tomorrow. Okay, so tomorrow maybe, I mean, hey, we are going to finish this book, so we will give our best. So, but for today, I just need to take care of that power connection issue. So, let's just do my best. Okay, and let's just dive into this, and yeah, everything is fine. Okay, so this is the command. So if you have installed this, once you see this, you're good to go. Okay, install on Windows. So and just go to this URL and follow the instruction for installing Rust at the same point of installation. Okay, you are prompted to the Visual Code Studio. This is provide a link and okay, if you are into this, follow this guide. Okay. um, I'm not going to how to install Rust in very detail because that thing you can easily do that. So maybe we can just focus on more complex topics. So once you do this, just if you're on Linux, just copy the. I think if you're on Linux or I think that thing for the. Sorry for that. So now you have a Rust 1.870. Okay, 87.0. So now we are good to go. And if you put this, I'm in Linux. If you're in a OS or partial, sorry, if you're in a Mac OS or partial. So this is the path of my Rust installed. Correct path, still Rust isn't working. Updating and install editing. If you want to update Rust, you can use this command. Install, you can use this command. But I don't know this command. Okay, it works, but there is a few catches you need to aware of. Is that when you add dependencies in Rust, like more cracks, kind of like packages. Um, if you install Rust, I don't know whether they also installed other packages you just installed that are related to Rust. I'm not sure about that, but let's cover that in future. Maybe maybe we can just think about it later, but you need to think about it because if you yeah, most software systems will do that, but some of them are not. If you are using NeoVim, it's kind of editor. If you know NeoVim, it's kind of a VS Code. It's not a VS Code. It's kind of a command line editor. It's relatively it's popular and software development. It's a really good editor, and you can it's a fully very configurable editor. It's not like a VS Code or some other editors. It's like fully configure. You can configure as much you want. You can do anything with it. You can change anything in it. So you can add a lot of packages, but once you delete, I think once you deleted the new one itself, the packages that are come into this maybe stay in your computer. It's going to be waste of memory, right? Even though you are not using. So so it's going to be a waste of memory. So you need to take care of this. Not only for this, for every package you are installing your computer or any system, you need to take care of it. Some of the software will do that for you, some of them are not. You need to manually do that. So so that's something you need to keep in mind when you're installing new any kind of softwares. Okay, I'm just telling this for just knowledge, general knowledge. Local documentations for Rust also include local copy of documentation so that you can read offline. So this thing is one of the good feature in Rust. So you don't whenever you add a package to your CRAD or the the actual folder you are working on, um, the docs also come with it. What I'm what I'm saying is basically if you add some packages to your folder, you can also read the documentation of that package. You don't need internet. It's also just when the package when you install the package, it also installs the documentation according to that package. So you can just read it in offline. So it's kind of a web page which run local. So it's kind of a relative, it's kind of a good feature, you know. It's not it's not kind of a, it's a good feature really. Anytime at a 5 standard library, you are not sure what it does, how to use it, use the application interface, application program interface documentation to find out. Okay, I will show that how you can do that. So let's just go through this quickly. Editor. So these are okay. These are the simple things. Working offline with this book. Okay, so this is a package manager, and this is a mm, this is new keyword is kind of a creating a folder. You can think of it as like if you are coming from the web development, and if you create an let's say if you have a Next.js project, you create a Next.js project, and you have these sorry for that, you have this folder structure where you have a root folder, and inside of it you have the source folder and public folder and some of the JSON files, package.json, tf typescript ts typescript dot json, and a lot of things, right? So this is something like that. Cargo is the same thing like that. It's kind of a, when you create something with let's say it's kind of a project. If you create this, let's just uh, wait a minute. I have this, and uh, it's um, okay. If I create this, maybe we can just hello. Okay, so before that, yeah, it's going to be it's going to be create a folder in my Rust folder. Now I'm inside a Rust folder called Rust, and if I use this command, it's going to be installed. I'm create a hello folder. Let's just see. You can see here it's installed. Sorry, it's created a hello directory. We cd into this. Sorry for that. Cd hello, and list this, you can see the now you can see it's much more like a web development. And if you're familiar with Rust, or if you're familiar with Next, or something like that, JavaScript frameworks, mostly most of them do the stuffs like this, organize the code like this. It's like a source directory where every code going to be live, and the cargo.tml, it's kind of like a json dot package.json in web development. It's kind of like a saying that these are the these are the dependencies you just added for this project. So if we do this soc, and you have a main.rs, this is the main file. So this is the starting of the file. Okay, there's a cd into this. Yeah, here what you're doing is, let's just okay, let's just wait a minute, let's just open this file for you. Cargo, sorry for that, YAML. So you can see clearly that this is a package name. So we just mentioned as a hello, and the version and the edition. Okay, and the another thing you have to take care about is that this dependency spot. Okay, so this part is where you need to mention your dependencies. Basically, if you want something, you can add something here and run your code. It will install your install the dependencies you just mentioned. So if you run this code, let's just put this here. You can see this thing download cargo.r. This is a package, and this is also a package. Let's just kind of what I'm saying is kind of like library. So let's just now let's just open this file. Here now you can see that we just added these packages, right? So there is two way of adding package to your project. One is I just showed you, and the second one is you can write something here, the package you need to want, and the version, and that is common favorite. And so once you finish that, and you can, if you run the command, it automatically install those packages you just mentioned for you. Okay, you don't need to think about this so deeply. Just it's just a file containing all of the dependencies name, all of the dependencies name. Okay, so you can, if you want something, you can add those to a file or use this command cargo.r. Nothing more than that. So okay, this will catch the download for this package. You will don't need to download them later. Okay, once you download them, you don't need to download them later. You have to run this command. You don't need to keep the get dependency folder. They're basically saying that create this get dependency folder and add the dependencies to it. So it's basically once you put all the dependencies you need to this folder, you don't need to download them again. Okay, download them later. You can just good to go. You can code in offline. If you have run this, you can flag with the rest of the program. Okay, let's go to the next chapter. This is a hello world program, and just basically let's go through this quickly because let's let's code. Okay, so first of all, here we are creating some directory and cd to it, and make another directory and cd to it, and it's for Windows, just for nothing more than that. We are creating a project folder, and inside of it we are creating a hello world folder. I think you can understand this. Running a command, this is the main function. Okay, so all you need to do this. Okay, let's just show you a demo, and let's just clear. I'm PWT. You can see here where this is my actual file path. Okay, so you don't need to just leave it this part, and you can now we are in rust.hello folder. Okay, we have created some package inside the rust folder called hello, and inside of it we have this cargo.log or cargo.toml and src folder. Inside of it the main function. Okay, so the main rs file. So let's just use this cd to src, and you can see nvm.main.rs. Okay, this thing is already written by default. If you installed, if you created some package, if you created some package, and it's going to be installed, it's going to be give you this kind of a template thing where it's going to be have this HTML file. It's going to be created the source code, a source folder, and inside of it it's going to be a starting point of your code. So it just runs it. So if you want to run this code, we are just done the same thing. Okay, if you want to run this code, you need to let's just wait a minute. Okay, okay, and now server tmx nvm main.rs. Now we have this, and now we can run this. Okay, we need to run this command. All you just need to do is just rust c main.rc. rust c main.rc. We run it, we compile it. So if you did this, it's not going to be show the output, because you just compile the code, not run the code. It just compiled into some intermediate representation or binaries. Okay, so in order to run this code, you can do something like this: main.r. See, now you have the output. You can see here, hello world. Okay, that's how you can run the code in Rust. Okay, if you have come from some other languages, if you come from C, something like that, it's going to be the same process. First you need to compile the code, then you run the code. Simple, right? So on Windows it's same thing, but this is going to be converted into executable file, exe. Okay, this is the main function. So let's review this. Hello world program in detail. Here's the first piece of puzzle. So this is the main function. So what do you mean by the main function? Main function is basically that's the execution begins. Okay, it's a starting point of the execution. If you run this code, maybe I can let's just give you an example. Just I have a foo, another function called foo, and same thing, print ln and uh, subscribe. Okay, that's it. So this is another function. So this, both of them are functions, right? So this is a main function, this is another function. So what I mean by that function? So I think I hope you have some experience in programming. So I hope you know what function means. So let's just a reusable block of code, something like that. So this F1 keyword just basically mentioning that, hey, I'm going to create a function. Okay. And the second thing is, what is the name of the function? This is going to be main function. This is going to be foo function. It's just a name. Okay. And this parenthesis, just brackets. Yeah, it's parenthesis, I think. It's a bracket. Okay. So it's basically saying that whether this function going to be get a parameter. If do, then mention here. If don't, leave it nothing. Okay. And this is a block. When you call this function foo, just let's just foo. When you call this function, it's going to be execute this block. Whatever inside of this block, that's going to be executed, right? So now what I'm saying is, what is this difference between these functions? So you cannot name another function something like this. You cannot do that, because this is a built-in keyword. So you cannot name another function called main. Okay, there is only one main function inside a single file. Okay, so then you can have multiple other functions, basically different names. So the difference between both of them is just the starting point of the execution. When the machine when your computer going to start the execution, okay, I have this file and I'm going to execute. The starting point is going to be here, not here. Okay, that's the main function all it do. So main function is the starting point of execution. So it's going to be come here and okay, they want to print this line. Okay, hello world, just print it. Then they called another function. So it's going to be search whether this function is mentioned in this file or not. If mentioned, then it's going to be, yeah, we have the function called foo, and we are going to execute this block. So if we did this, just a minute. Uh, just wait a minute. This is how call function we call. Okay, let's just do this. We can cover functions and these kind of something like a macros, these things later. But for now, what you need to know is in function is the main block. That's all you need to know. Function keyword is for declaring function, main function is the main function, and parentheses brackets for whether it's going to be have a parameter or not. And this thing is basically println is a macro. So macro, what I mean by that is it's going to be it's a kind of a pretty advanced topic in Rust, but what it does is basically whenever it's not like a function, it's behave like a function, but it's not. Whenever you call some macro, this execution not jump to that, but before compile before you compiling the code, what here the line the exact line 7 going to be replaced by the code which are in this macro. Okay, so what I'm if I am defining some function called just function called print l, and if I do that, okay, let's just I'm not now I'm not creating macros, I just creating some, sorry for smashing my mic. So I'm just showing in a function way. If you create this, it's going to be call, when you call this, the execution going to be jump here. Okay, but macros is not like that. Macros is macros behave differently. It's not going to jump the execution. Instead, before the compilation, the code copy paste, the code will copy paste. It finds the macro and copy the code inside of that macro and paste it here. Nothing more than that. Okay, that is what just macro means. Yeah, I know I'm just going bit detail here, which is not in this book here. So, but let's get into that. Okay. Okay, function, and this the wrapper, this function body is wrapped by this wrapper. Just okay. Curly braces and around for functional bodies, and good style to place a open curly braces on the same line as a function declaration. Whatever. The body of the main function holds the following code, and this line all is supposed to print a little work in a little program. It print the text to the screen. Okay, that's it. Print ln calls raster macro. Yeah, I just told you that. Print ln is a macro. Okay, it had a function instead. If you had a function instead, it would be entered as this. There is a two kind of way you can print things. One is that one is this println macro, and another one is a function println. Okay, both things doing the same thing, both of them doing the same thing, and but it's a macro, it's a function. Macro replace the code, function will not jump the execution. Okay, we'll discuss Rust macro in chapter 20. So okay, yeah, that's why I just said you macro is kind of a advanced topic, because they explained this in a way far in the okay, chapter 20. Okay, for now you just need to know this means you're calling a macro instead of a normal function. Okay, macro don't always follow the same rule as a function. This is what I just said. Macro don't always follow the same rule as a function. Understand? Just 1 minute. Macro does not follow the same rule as a function. If you are watching my live, just comment If you're watching my live, just comment, bro. Going to be much more fun. Okay. Second, you see the hello string. We pass this string as argument to the printer. So argument to the printer, and the string is printed to the screen. I hope we will cover this a bit later. What is augmented? So it's basically some amount of data that are sent to the function or a macro. Yeah, I just can you remember I just mentioned this? If you put something here, if this function gets some data, you need to mention here, right? If I mention something like story one, and if you call this with some string here, something like room, this string going to be centered to here. Then this variable capture this string and we can print here using print. You can use this variable to for anything you want. You can print it, you can change it to another thing, you can do anything you want. Okay. Third, we enter semicolon. So semicolon is basically for end of line. So if a single line is entered, you need to put semicolon end of it. Okay. Otherwise, it's going to be error. So so indentations and multiple lines is not important in Rust. Okay. Semicolon is just indicating that end of line. If you can use multiple lines for a single line, we are going to see that in future. And now all you need to know this: if a line ends in a Rust program, you need to put the semicolon at the end. Expression is over. This is basically that this expression is over. The next one is ready to begin. Most line Rust and okay. So this is the way we run the code. We just run it, and you can list this. Okay, this is one of the important thing you need to see. So you can list this. You have here that before compiling our code, we don't have this main ors. Sorry, we don't have this main thing, but we have this main rs file, but we don't have this main thing. So now we have this is because this is the after compilation there is a, I think it's a binary. So after in order to run the Rust code, you just need to follow two steps. One, first you need to compile the code. Second, you need to execute the code. Okay, first you compile it, it's going to be converted into a binary or machine code, low level code. I think it's a machine code, and then you just execute that code. So this is the compiled code for this main function. Okay. This shows the source code file and the executable file. So on the Windows, but main on all other platforms. Okay, executable file in Windows, on other OS it's just a main. And using Windows file containing deeper information, extensive and platform here. Okay. Just wait a minute. If a main RS is your hello world program, that's line is on the terminal. If you are more familiar with the dynamic language such as Ruby, Python, or JavaScript, you might not be used to compile and run program as a separate step. Hmm. If you are familiar with Ruby, Python, or JavaScript, you don't need to compile the code first because they are not they are not they are they don't have this compiler. They have this interpreter thing where it's executes the program code line by line instead of compiling the entire thing first, then execute them. Okay, so two separate steps in compiled language. In interpreting language, it's going to be a single step. Yeah, before you used to compile and separating a time compiled, meaning you can compile a program giving the executable by someone else. So, well, what that meaning is that basically meaning that you can once you compile the code, you don't need this code anymore. In our case, if you consider compile after compile this main.rs, you don't need this code anymore. Okay, you don't need it. You have this executable code. Okay, you can share this to anyone, so they can run it easily. Okay, they don't need the actual source code. All they need is the executable binaries, machine learning code. Okay, if you are more familiar, okay, and again, some others they can run even without the Rust installed. They can run even without having Rust installed. If you give us someone this like Ruby, Python, JS file, you need to give the source code, not the binaries, not the machine learning code. You need to give the source code in order to run the program. And another thing you need to another thing they want is that the interpreter, they need to have the interpreter. So without them they cannot implement, they cannot run the code. But those language only need one command to compile, run your program, everything is straight up. Okay, okay. Run C for fine simple program, but as your project grows, you want to manage all the options and make it easy to share your code. Next, we will introduce you to cargo tool. Will help you to okay. So next, we are going to see this cargo package. It's a very cool package. Okay, now the next thing is cargo. It's just a package manager. So you can I already told you, just a package manager where you install packages. If you want to something like some kind of so maybe you can put this like, let's say you want a data type called vectors in Rust. It's kind of like array. Okay, it's array. Okay, you cannot it's not I think it's not built in defaultly, because you need to add this CRUD to your main scope, then you can use the vec type. So we will see that in a future, but we just added here. Just wait. Okay. Now I just, you can see here, you can see the cargo.tml file. So this is where your you can if you visit this file, you can see um, what are the dependencies you just add to your project. Okay, nothing more than that. It's just a package manager. Whenever you need a package, you are going to mention this file or you need to use this add command, cargo add and the package name, then it's going to be download the package file, nothing more than that. Okay, it's going to be create a new we already seen this, which is create a new project and cd to it, which is basically go into that directory, and this is the cargo.tml file, how it looks. Okay, this is the project name and the version and the edition. Okay, that there, yeah, if you don't if you didn't add any dependencies here, you will not see anything here. But if you added something, the name of that package is going to be displayed under this dependencies. Okay, that all it is. And I'm going a bit fast because there is a lot of things. It's basically for pure beginner, I think. Let's go into the coding part as fast we can. Okay, due to source code, maybe you can just read this line. This is a timer for, okay, format, which is a configuration. The first line is a package, is a section handling the indication of the following statements are. But as we add more information, as we add more files to this package, we will add another section. Okay, next 3 lines enter the configuration information. Cargo needs to compile your program name and version and the edition of the rust to use. We'll talk about the edition here. Okay, last line dependency, start of the each section. You need you to list any of the project dependencies in the rust package of the code or refer to the crash. So crash, this thing in this is a thing. So in the rust ecosystem, you are not calling you are not saying something like library or something like that. They will call them as a CRAD. So there is a two type of CRAD. We will see them later, which is a binary CRAD and the library CRAD. So we'll cover that later. So all you need to know is CRAD is kind of a file. We don't need any other CRADs for this project, which is we don't need any other file for this project. But we will first this chapter 2. Let's go into the chapter 2. That's where the project chapter is. Okay, the another thing we need to run cargo generated a program for you. So cargo generated the hello program for you. Yeah, we just seen that when we created the new project in our in this folder. Maybe we can just cargo new something like hi. So now it's going to create a hi directory, and if you list this, if you cd the source, sorry, it's a source, the cd the source, you can see the main data. Yeah, it's already returned. Okay, that's what I was saying, just already returned for you, nothing more than that. Just like on a return zone, the difference between our project and the cargo generator or placed code in the directory, associate directory we have, and cargo TML configuration file in the top of top directory. Okay, that makes sense, right? So cargo expects you to a source file to live inside a source directory. Okay, cargo expects your source file where you write a file to your source directory. Understand? The top level project directory, which is here, which is top level directory, which is hi. Hi is our top level project. It just this is the top level project. I mean top level directory. Basically, we can say a root directory for this particular cargo project. Okay, for this sorry, it's not cargo project, it's a rust project. Okay, if you start a don't use a cargo as we did in, okay, where we just Tableau project tree cargo expected resources and project tree. The Tableau project directory is just for, okay, readme file, license information, and configuration file, and anything is not related to your code. So whenever you write a code to a project, you need to write to this source directory, okay, inside of this source directory. So not in the I directory, which is the root directory of this project. Okay, so but it's going to be have readme file, license information, and configuration, something like that. If you start a project doesn't use cargo as we did with the hello world program, you convert to a project that does use cargo. You can convert it to a project. So if you write a program without a cargo, just the rust and compiler, you can convert to a project like cargo project. Move the project move the project to the resource directory, create a appropriate tml file. Once you one easy way to get the tml file to is to run cog in it. So this is okay. If you write if you created some let's just give you my example. uh let's just clear all of this. It's kind of a messy. So we are, let's say, so we are inside of a hello, right? So what we have here, so this is, okay, maybe hello itself is a project. Okay, if you want to create some directory which is not a project here, okay, we are going to create a some directory, just a folder called hey, okay, and create it. Let's list this. You have the hey folder and cd to hey, and let's this, you don't have anything in it, you just create a folder. And if you put this command inside a cargo in it, now what will happen, just see. Okay, you're not created the cargo project with this command called cargo new, the project name. Now we created the project tree by yourself, and you want to convert this directory to a cargo project. Then you just go to the inside of that directory and create a cargo.unit. If you do that, it's just going to convert that current directory, just a folder, into a cargo project. What is mean by cargo project? Just create your cargo.tml file and the source directory. More than that. And the inside of the source directory, it's going to create a main.rs. That's it. Okay. So the major will create automatically. So I think there is a lot of, we just created a lot of things. Maybe we can get rid of all of them. What are the things we have here? Yeah, rms.rf. Hey, I just basically deleting this files folders, so we don't need them yet. We don't need that anymore. Okay, if you start okay, built and running cargo page. Now let's look at what's different when you build and run hello program with the cargo. From your directory, build your project by entering the following command. So if you put this command, let's just, now we are inside of this cargo project. Okay, sorry, we are inside of this hello project, so it's a cargo project, and we have source and cargo lock and cargo town file. So if we do this cargo dot build, okay, it is sorry, it's a cargo, not it's going to do a lot of stuff, right? Downloading these kind of downloading. What it's basically doing is that it just if you add any dependencies to your project, it's going to be download all of them. Okay, and if you, how do you say, this command creates an executable file in a target slash debug slash hello cargo .exe rather than your current directory, because the default build is in debug build. Cargo put the binaries in a directory named debug. You can run the executable with this command. So it's just basically simply saying that, okay, we are in PW. Okay, now we can here you can see that this is a executable file, right? Binary. So this file binary live in the folder called src, right? It's inside of our hello project, right? So if you build this, so we are compiled this specific file, and that binary lives in the current directory. Okay, but if you build this, it's going to be it's going to convert the entire project into executable file. So it's not just okay, and put it in not here, put it not here. So you're not going to here, you're not going to see here. So put it somewhere, something like here. You can see a new directory called target is created, and inside of it you have this debug. Okay, debug, cd to debug. You can see the, I hope you can see this build folder, and inside of it, and you have a bunch of things. You can think of it as these all binaries. So that's what I was saying. Is that it's not going to be, if you compile a code, it's not going to create a binaries under the same folder. If you build this command, so it's going to be a project level build where all the codes that are included in your main file are converted and compiled and converted to executable, I mean binaries, and put this in a target.debug.hello.cargo. Okay, target.debug debug slash. So just wait. Oh, sorry. Target. And another thing, this is for Windows thing. Because should be printed in your terminal. Okay, let's just go through this today, and tonight I'm going to be live streaming again. um, I have a little job to do, so I cannot avoid this now. So let's just go through this by, okay. And now we are going to build, okay, this project does not, okay, you won't ever need to change the file manually, cargo manage it for you, where it is. And if it goes all well, it's going to be print hello world should do the drive. Okay, running cargo build for the first time also cost to create a new file at the top level, cargo.log. So you can see we have a file called cargo.log. So here you can see that cargo.log, and this file can keep track of the exact version of the dependencies of your project. Just keep track of the versions of your dependencies of your project in your project. This project doesn't have a dependencies, so the file is bit spare. You won't ever need to change this file manually. Cargo managed it for you. Okay, that just basically makes sense. We just built a project with a cargo built and run with it this, but we can so use this to compile the code and then run the result on the one command. So what they are basing this, we just build a binaries using cargo build, and it's going to be in the target folder. So but we are not run the code yet. So it's going to be compiled and converted to the binary and put it in the target folder. So we can do this in a single command. Once you compile, just run the code. Cargo.run, it's going to compile the code and run the code. I don't know why my build is failing, but maybe hello world. Sorry. Wait a minute, I just made a mistake. Cargo. Hello. Just one CD2. Hello. One cargo build. Maybe this is, you can see the actual binaries is located here. Maybe we can just run this command instead. Here you can see the hello world. That's it. And using cargo is more convenient than the have to remember cargo build then run it. Okay, that's it's more convenient because you can use a single command and it's going to be built and run at the same time. For you, notice this time we don't output the indicator and our file, and just so it didn't rebuild but run it had to source code cargo would have rebuilt the project before running it and okay, understand. The cargo also provide the command line check. So this command quickly check your code to make sure it compiles correctly or not. Okay, this is a new command. This is one of the cargo command for quickly check your code, make sure it's compiled, but doesn't produce an executable. So it's just basically saying that it's not going to create executable in somewhere and put executable and put it in somewhere. It's going to be compiled and then the code. Ah, interesting. Hmm. I'll saying that if you run this code, if you doesn't change any, if you doesn't make any change to your code and you run the code, run this command cargo.run again, it's not going to rebuild the code again, but instead it's going to be use the rebuilded binaries for you. it's not going to be rebuild the code again. So it knows that the code is now changed, so we can use this. Just hold bind. Why do you not executable? Often cargo checks much faster than cargo build, because it skips the steps to produce an executable file. If you are continuously checking your whole while your work while the code, and okay, the cargo check is speed up the process, letting it. So it's a cargo check is kind of like it's not going to build a binaries for you. It's kind of like a it's going to be create a it's going to be execute the file at the instant. Okay, it's not going to be create a binary and put it somewhere. So because it takes time, right? It's going first first it need to compile, then put it somewhere, then run it, execute it. So cargo check is not going to be create and put it somewhere. It's going to be compile and run it instantly. So it's much faster. If you're in a serious development, you're going to use this a lot, because build is going to be much slow and using more resources. Let's recap. Create a project, cargo.new, build a project, cargo.build, build and run the project, cargo.run, build a project without producing a binary, cargo.check, and instead of saving the result of the build in the same directory as your code, cargo stores it in this directory. Okay, so all makes sense. And additionally, advantage of cargo is no matter operating system we're working on at this point, we are no longer providing any specific instruction with. Okay. So Mac OS and Linux, we are going to have the same command, but Windows it's kind of a bit different. Build for release. When your project is finally ready for release, you can use it to build release to compile with the optimizations. It's kind of like if you are going from the web development world, something like a Next.js, you have this build command. So npm build. So it's going to be convert your entire code into optimized code, kind of like a static files. So it's kind of doing the same thing with us. Like optimization, each command will create an executable integer and in release target at release instead of target at debug, because you are in a release mode. In there, it's a build. Optimization makes your run faster, but turning the lengthy the time it takes for your program to compile. And this is why two different profiles, one for development. Okay, this thing you need to take this carefully, because one for development, rebuild quickly very often, another for building final program, where you have a program and you are going to deploy it in some server. So whenever you are going to do that, you need to use this build command. You get a user one rebuild rapidly, that will run fast as possible. Okay, that will run fast as possible. If you are benchmarking your code on codes run, be sure build run. Okay. And it's convenient, simple project, a lot of overall, it just starts. Okay, this is how it's where we are now. I think we just completed the first chapter. Let's next dive into the second chapter, but I think I will back to the stream again after 2 or 3 hours. After 2 or 3 hours, I think I have a little work to do, but thanks for watching, and please subscribe that to our channel. And if you like our live stream, make sure you click the like button. And if you